all the way through your dry lab, you should have one color on the left side and one color on the right side. You shouldn't be flipping colors. Okay, that's really important. That'll help you get this straight. You need to have all these parts labeled. Remember that you've got red cat paws over here as a reminder. And over here on this side, being run over by an ox is a negative experience. Okay, yeah, you need to write those in. That's 6 easy points on each one. Make sure you write these in on each side because there's 6 easy points. Don't forget to write these in. That's 3 easy points. That's always, yeah, as long as you stay the colors, right. That's fine, whatever yours is. It's different from mine, that's fine. Okay, now, all of them will be voltmeters except for this next one. Did you notice underneath it's also nickel cadmium, but it says something different. What does it say? Electrolytic. You ever use rechargeable batteries? Okay, this one that we've got up here is when we're using the battery. Then what do you do when the battery runs out? Recharge it. So we're going to put it on a charger where we're going to need a generator. So the next one down is going to use a generator in place of where the voltmeter is. Make sure you've connected the lines with a voltmeter, because if you don't have a complete circuit, it won't work. Okay? So on the next one, we're going to use a generator. Same nickel and cadmium, but we're going to use a generator. So when you use a generator or where you have an electrolytic battery, that means you're recharging it. That means you're forcing the electrons to go the way they don't want to go. That means your overall voltage has to be negative. Okay, so this time we're going to flip the top one. So when you have an electrolytic, you flip the top. So we're going to go, whoa, hello. We're going to go to the next one here, which is also a CD, Ni or NiCd, but it's electrolytic. Okay, so you're still going to have your salt bridge. But this up here, you're going to have a generator, and I'm not going to try and draw the generator. Generator. Okay? We're still going to have a salt bridge, so we're going to write salt bridge. We're still going to have the cations heading to the cathode, and the anions heading to the anode. These help balance the charge. We're still going to have water in here. Okay? We're also going to have on this side anode, oxidized, being run over by an ox is a negative experience, and the negative. Over here we're still going to have red cat paws, reduction, cathode, and positive. Okay, but this time we're going to flip the top one, which was nickel. So nickel is going to be, let me get this right over here, get the highlighters going. For me, it was yellow. Okay, and this side is going to be pink for me. Okay, so over here I'm going to have nickel. I'm going to have nickel plus 2. Okay, so you're looking for a thing. Over here, the nickel is going to reduce and go into solution. That means I'm looking for the equation that goes nickel goes to nickel plus 2 electrons. Now up above it was a negative 0.25, right? But now we've switched it, so the E for this cell is going to be positive 0.25 volts. Then on this side, we're going to be looking for the cadmium. Cadmium here is going to grow. Cadmium plus 2 here is going to go onto. So I'm going to start with cadmium plus 2 electrons gives me cadmium. And the E for this one was 0.4, right, up above. So down here it's going to be a negative 0.40 volts. So each cell, add those together, and we're going to get a negative 0.15 volts overall. What thing have I forgotten to do? Drawing the connecting wire, and it doesn't have to be a straight wire. It can be fancy if you want to, like this. Okay, but I also need to put in electrons are going that way, both sides. Okay, that gives me 20 points. Okay, so the next page is yours to do. They are both voltaic cells, which means what? What should my overall voltage be? Positive or negative? Positive. Now, the nice thing that you guys need to know is next time we're going to do a lab where we're actually going to put batteries together and see what their voltages are. And the next time you're going to have a little quiz on drawing a battery, a voltaic cell, and an electrolytic cell. And then we're going to move on. Yeah, we're going to turn this dry battery cell lab in next time, and then you'll have a wet battery next time that we'll actually do lab. Okay? Any extras after you've done all of your stuff, they're just extras. You can recycle them. Yeah, you've got, well, you don't have time to finish all of it, but you can finish some of it. So I do have baggies. They're up there by the login area over there. You're welcome to grab a baggie if you're not going to stay during tutorial. Okay? Okay, so we were working with electrochemistry. Oxidized is LEO, loss of electrons is oxidation, and reduced is GER, gain of electrons is reduction. The saying that goes with that is LEO, the line says GER. If that doesn't click with you, you can use oil rig. Oxidation is loss, rig, reduction is gain. These are some examples of oxidation and reduction. So sodium losing electron is oxidation. Fluorine gaining electron is reduction. Barium losing electrons is oxidation, and sulfur gaining electrons is reduction. This is a basic cell. This one is for copper and copper +2 and gold. You look on your reduction table and you find the tallest one, the one that's up highest on the reduction table. If you don't have one, you can grab one or Google one. The reduction side is going to be red cat paws. And the oxidation side is being run over by an ox is a negative experience. This has 20 points, so you need to be able to label all of these parts on a battery. Okay, next up is the first one on your dry lab. We've got that set up for you already. The beginning of this lecture that you are seeing, it was this is where we started. So there you go.